Binomial addendum, page 4. Number 7. 3-digit numbers are constructed from the digits 0 through 9, using each digit at most once. How many such numbers can be constructed? Okay, so just one tricky thing here. When you're making 3-digit numbers, numbers that start with 0 don't count, right? Because like 010 is actually not a 3-digit number, it's a 2-digit number. So in the first slot, you can put any number except for 0, right? So that would be 9 possibilities for the first slot. In the second slot, you have the 8 remaining from the 9 that you selected in the first slot, plus you have 0 as a possibility too. So that would be 8 plus 1. So that would be 9 for the second slot. And then in the third slot, you would have 1 less, which would be 8. So actually what you're going to do here is 9 times 9 times 8. Let's do that. 9 times 9 times 8. So the number of possibilities for part A would be 648. Part B, how many such numbers end in 0? So in this case, what you got is you have the last slot filled with 0 for sure, and then you're going to fill in the first 2 slots. And in this case, the first slot obviously is not going to have 0 in it because you put it at the end. So there's 9 full possibilities, right? You don't have to take out the 0 because it's already taken out. And then the second slot, you could have any of the 8 remaining ones. So that would be 8 times 9, which would be 72 possibilities. Number 9. 10 students sit in a row of 10 chairs. In how many ways can this be done if there are no restrictions? Okay, so basically, if you have 10 slots and you have 10 different ways to fill them, that would basically be 10 times 9 times 8 times 7 times 6, blah, 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 which would be 10 factorial. What is 10 factorial? We'll do 10 math probability factorial. 3628800. So it's 3628800. How many ways can this be done if students A, B, and C insist on sitting together? Okay, so this makes the problem quite a bit more complicated. We're going to divide this up into 2 parts. First, what we're going to do is we're going to assume that instead of 10 slots, there's going to be 8 slots. And the reason why we're going to choose 8 slots is because if you always have A, B, and C sitting together, then really there's only 8 different ways or 8 different slots to put things in. So like, for example, if A, B, C want to sit together here, then the other slots are free, but A, B, C are going to be in this 4th slot as a group. Okay? So the other thing we need to keep in mind is when A, B, C sit together, there's different ways for A, B, C to sit together, right? If you have 3 chairs and A, B, C are going to sit there in different orders, that's going to be 3 times 2 times 1 also, right? So there's 6 ways for A, B, C to sit in their block, right? And then how many ways are there to line up the 7 people who don't care where they sit and the block of 3 people that are going to sit together? How many different ways are there to do that? Okay, well there's 8 slots, and there's 8 times 7 times 6 times 5, etc. ways to fill them. So there are 8 factorial ways of filling the 8 slots. And then, no matter where we put A, B, and C, we know that there's 6 ways to order A, B, and C within their block. So we're going to have 3 times 2 times 1, or 6, multiplied times 8 factorial. Okay, so first we're going to do 8 factorial. And then we're going to multiply it times 3 factorial, or 6. And we get 241920. Okay? All right. Number 11. Number 11, consider the letters of the word Monday. How many different permutations of 4 letters can be chosen if there are no restrictions? Okay, so basically Monday has 1, 2, 3, 4, 5, 6 letters. We're going to choose four. We're going to choose 4 of the letters to fill 4 slots in different orders. So that would be 6 choices for the first slot, 5 for the second, 4, then 3. So it would be 6 times 5 times 4 times 3. You could do that with 6 NPR 4, or you could do that by doing 6 times 5 times 4 times 3. Oops. Times 3. Okay. So the first one is 360. Now, how about considering that 2 vowels are not together? Okay. A lot of times in probabilities and permutations, combinations, if you have a complicated situation which has many different scenarios, like this one, for example, you could have the scenario where one vowel was chosen and the other one wasn't, so you don't need to worry about where they're placed. You have the scenario where no vowels are chosen, so you really don't need to worry about it. You have the scenario where both vowels are chosen and you need to worry about it. Sometimes what's easier to do is to take the opposite of what they're saying and try to figure out how many combinations there are or permutations there are for the opposite situation, and then just subtract that from the total, and sometimes that's easier. So let's try that. So the opposite of 2 vowels are not together is that 2 vowels are next to each other, okay? So what are the possibilities that 2 vowels are next to each other? So basically that would mean that if you do have 4 slots, that the vowels are placed in this position, this position, this position, this position, or this position, this position. There's basically 3 ways for the vowels to be adjacent to each other with the 4 slots, right? And there's only 2 vowels in Monday. There's O and A. So for each one of these scenarios, O could be first and A could be second, or vice versa, right? So there's 2 possibilities for each one of those. So let's see. Now let's say in the first situation, if you already know that 2 vowels are placed in the first 2 positions, what are the different ways we could fill the second 2 positions? Well, there's 6 letters, but we've already chosen the 2 vowels, so there's only 4 left. So basically that would be 4 times 3 different ways, right? And then same thing for this one. This would also have 4 times 3 different ways. And this would also have 4 times 3 different ways. So each one of these sequences have 12 different ways to fill the other 2 slots that are not filled with vowels. And remember, there's 2 ways to fill the vowel slots, either OA and AO. So really each one of these is 12 times 2, 12 times 2, and 12 times 2. So that would be 24 times 3, which would be 72. Okay, so there's really 72 ways to have O and A next to each other in these 4 slots. Then we compare that to the total number of ways to have these 4 slots filled with any numbers. And then so the different ways of filling in the 4 slots where 2 vowels are not together would simply be 360 minus 72, which would be 288. Number 13. Alice has booked 10 adjacent front row seats for a basketball game for herself and 9 friends. How many different arrangements are there, assuming that there's no restrictions? So this would be a typical problem. 10 slots, choosing from 10 different ways to fill them. 10 times 9 times 8 times 7, etc. So it's 10 factorial. We did 10 factorial before, right? 10 math probability factorial 362, 8800. So 362, 800. B. Due to a severe snowstorm, only 5 of Alice's friends are able to join her for the game. In how many different ways can they be seated in the 10 seats if there are no restrictions? Now, normally what I would do is I would make the 10 seats, and then I would figure out how many different ways there are for Alice's 5 friends to sit here. Now, this is a weird situation because a lot of the seats are going to be empty, right? So in this case, it's better to invert the situation. Instead of making 10 slots, which represent the seats, we're going to make 6 slots, which represent Alice plus her 5 friends, so 6 people total. And then instead of filling the chairs with people, what we're going to do is we're going to take the people and put in their hands a ticket with the chair number written on it. So there's going to be 10 possible tickets, and the first person can choose from 10 tickets, the next person can choose from 9, 8, 7, 6, 5. If you want to do this in the calculator, it would be 10 permutation 6 because you're choosing 6 numbers here. Let's pull this out and we'll write 6. That's the same thing as doing 10 times 9 times 8 times, 7 times 6 times 5. Okay? So the answer is 151, 200. Okay, now this last one. How many different ways can they seat if 2 of Alice's friends are to sit next to her? Okay, so let's take this one step at a time. So if you have Alice, how many different ways could Alice sit in the 10 seats to start out with? Well, you would say 10, except for the fact that she wants one friend on either side of her. So she can't sit in the first seat or the 10th seat because in that case, she can't have a friend on both sides. So basically, you have to eliminate seats 1 and 10, and you're left with the middle seats, the middle 8 seats. So there's 8 ways of Alice to sit in a chair, okay? And then she's got the 2 neighboring seats. She's got one on the left and one on the right. She would like to fill those seats with 2 of her friends. So basically think of that as she's got Alice's here. She's got a left seat and a right seat. How many different ways can she fill the left seat and the right seat? Well, she's got 5 friends there. In the left seat, she has 5 friends to choose from. The right seat, she's got 4 friends to choose from. So basically, she has 20 ways to fill those 2 neighboring seats, right? Then she's got 3 remaining friends. And those 3 remaining friends, let's use the same method that we used over here. So if she has 3 remaining friends, those 3 remaining friends can choose from the 7 remaining seats in any way. So that would be 7 seats to choose from the first friend, 6 for the second friend, and the third friend would have 5 seats to choose from. So that would be basically 210 ways. Okay? And so then we just need to multiply all these. We need to multiply 8 times 20 times 210. And that would give you the total number of ways to fill the seats in with Alice sitting next to 2 of her friends. So 33,600.